For this section, we're going to be talking about graphing quadratic functions using the vertex form, and then also how to find the vertex without vertex form. So we'll start off with a definition that says the vertex is the highest or lowest point on a parabola. So whenever you look at a parabola, you have two general shapes. The first is an upside down U, and the second is just a standard U. The vertex is this point, either at the peak or at the valley, the lowest point or the highest point. So from there we say that the axis of symmetry is the line passing vertically through the vertex such that it creates a mirror effect. So when you look at a parabola, the axis of symmetry says you start at this vertex, and if you draw a dotted line through it, the axis of symmetry now creates a mirror where the left side could be flipped over exactly onto the right side and vice versa. And this is true for any parabola you come across. If you draw a line straight down the middle of it, that is the axis of symmetry, what passes through the vertex, and you have that mirror effect again. Okay, so from here, we now introduce vertex form. Vertex form says f of x is equal to a times x minus h quantity squared plus k. The reason why this is useful compared to our normal quadratic form of ax squared plus bx plus c is because when we look at this form, we can immediately find the vertex. It's the point h comma k, given x minus h squared plus k. We also can immediately say the line of symmetry is at the line x equals h. And we can also say that the parabola will open up if a is positive or greater than 0, and it opens down if a is negative or less than 0. So now let's introduce the process for how to find vertex form. And it is a long process, but it's the only way to really know how to graph a parabola exactly, given any type of parabola you come across, other than the next method we'll introduce at the end of this. So, given any quadratic function, we say that the first thing that you have to do to graph using vertex form is to find the vertex form, obviously, which we will generally do by completing the square. Sometimes it will be a more basic problem that you can simply factor, but in most cases you will have to complete the square. And once you do that, you can then pull the vertex data from that. So we know the vertex will be the point h comma k. We can then find the x-intercepts, or x-intercept, or maybe no x-intercept will exist. Remember, you can always have 0, 1, or 2 solutions when finding these. From there, we will find the y-intercept. So remember, x-intercepts are found when you set the equation equal to 0. The y-intercept is found when you plug 0 into the equation for x. So we'll be doing both of those. And at this point, we now need to add extra points if needed to have 2 on each side of the vertex. And you should use the axis of symmetry whenever possible to find these points. So you always want to have a total of at least 5 points. So if you were to look at your parabola, you should always have the vertex, and then you should always have 2 points on each side such that they match using the axis of symmetry. In general, your graph will always resemble this concept that you see in this picture here. Okay, so let's go ahead and try this out. We want to graph g of x equals x squared minus 4x plus 5. It's not in vertex form. So the first thing we have to do is find vertex form by completing the square. So to complete the square, the first thing that we have to do is make sure there isn't a number in front of the x squared. Since it's just x squared, this is already done for us. We get x squared minus 4x. And now to complete the square, remember you always take the b term, ax squared plus bx plus c. You take your b term, which is negative 4, and divide it by 2 and square the result. This is completing the square, so we get negative 4 over 2 is negative 2 squared, which ends up giving us positive 4. So we are going to add 4 to the x squared minus 4x. And then, because we added 4 to this equation, we have to take the plus 5 and subtract 4 from it. Think about what this looks like. If we have x squared minus 4x plus 4 plus 5 minus 4, it looks like a totally new problem, but plus 4 cancels with minus 4, giving us what we started with exactly. So we haven't changed the problem, we've just rewritten it in a way that we can use to find the vertex form. So now we get g of x equals x squared minus 4x plus 4 is going to factor into x minus 2. Remember, whatever's in parentheses here of the square will always be with the x. So x minus 2 squared. And now we have plus 5 minus 4, which just gives us plus 1. We have now found the vertex form. So let's start off with the vertex. What is the vertex? Well, it's h comma k. Remember, our formula is a times x minus h quantity squared plus k. So h is always subtracted. So we are subtracting 2, that means h is positive 2. If it were x plus 2, then that would mean h is negative 2. It's always the opposite sign of what's with the x. So we get 2 comma positive 1. So now we have one of our 5 points. Now we need to find the x-intercepts. We can do this a lot of ways. The way that I'm going to use is setting this part of the equation, x minus 2 quantity squared plus 1 equal to 0. You could also set the x squared minus 4x plus 5 equal to 0, however you prefer. So we get x minus 2 quantity squared plus 1 equals 0. And now we'll start solving for x. When we do, we'll subtract 1 from each side to get the quantity of x minus 2 squared equals negative 1. To get rid of that square, we'll apply the square root function to each side of the equation, or we'll take the square root of each side, which gives us x minus 2 equals plus or minus the square root of negative 1, and immediately we can stop. Because we got the square root of negative 1, that means that these answers are going to be imaginary, which means they are not going to be points on this graph. we don't need to worry about them. There are no x-intercepts on this graph, which means we can now go to the y-intercept. The y-intercept will be found by just plugging in 0 into the function. So we get 0 squared minus 4 times 0 plus 5, which just leaves us with 5. So we just found another point, 0, 5. So as of right now, we have our vertex, we have our y-intercept, and that's it. If we were to make a table here, we'll go ahead and put the vertex in the middle because we're finding 2 points around it. We have the point 0, 5. So now we need 3 more points. One of them to the left of 2 and 2 of them to the right of 2. So we'll just go ahead and pick 1 since it's the easiest value we can pick closest to 2 to the left of it. And then we'll pick 3 and 4 as those are the next 2 values closest to the right of 2. And now we're just going to be plugging these values in to our function g of x. We can either plug them into the original function or into the vertex form. I'm going to use the vertex form as it's generally going to be easier to plug values into that. So, writing these off to the side, we have g of 1 gives us 1 minus 2 quantity squared plus 1. 1 minus 2 is just going to give us negative 1. Quantity squared is positive 1. Plus this 1 gives us 2. So we have the point 1, 2. And now we need to plug in 3 and 4. But we don't really have to plug these in. Remember, I'm going to go back to this page really quick. This note said to use the axis of symmetry whenever possible to add more points. And looking at this, 1 is the same distance away on the x-axis from 2 as 3 is away from 2. That means, according to the axis of symmetry, they will share the same y value. Think about that U shape. If we are at the vertex here at 2, 1, then to the left of it we have the point 1, 2. That means to the right of it, a distance away of 1, we'll have the point 3, 2. Which means this 4 should have the same y value as this 0 because the axis of symmetry. So this will get 4, 5. And we'll show that even more clearly once we start graphing. So I'm going to go ahead and put the graph in red so it's easier to see. I'm just going to graph the 3 points that we initially solved for, just to show you how you could also, with a graph, show that these 2 points would exist. So we'll graph our vertex 2, 1 right here. We'll graph the point 1, 2. And finally 0, 5. So because this is the vertex, remember it has the axis of symmetry running through it. And remember, the axis of symmetry creates a mirror effect. So this point will be mirrored the same distance to the right as it is on the left of the vertex. So It's a distance of 1 away from the axis of symmetry on the left, so there will be a point a distance of 1 away on the right, which is exactly at 3, 2, just like we said here. And likewise, this point is a distance of 2 away. So 2 away on the right will give us this point, which is at the point 4, 5, which is again what we did here. 2 ways of finding the same thing. If you prefer the table, use that method. If you prefer the graph, use that method. And either way, we connect our dots to get the final graph. We have the parabola that represents our function g of x. This is not an easy method. Don't feel too overwhelmed by it. But it is very useful, as if we had just taken the original problem we had, x squared minus 4x plus 5, we would have had no idea what points to start plugging in. It's not always as simple as 0, 5, 1, 2, 2, 1, and so on. Sometimes you'll find that these points end up being like 1/2, negative 5/4, in which case you never would have just went through and guessed all of these. So this method gives us an efficient way to go about graphing any parabola we come across. So I'd like you to take a moment, pause the video, and see if you can't graph f of x equals the quantity of x plus 3 squared minus 9 using the same method. Okay, so trying this together, notice this is already in vertex form, so we don't have to worry about completing the square. Instead, we can immediately jump to finding the vertex. And remember, the vertex is located at h, k, and h is always the opposite value of what's with the x. So instead of positive 3, we have a negative 3 for h, and k is negative 9. From here, we can now find the x-intercepts by setting this equation equal to 0 and solving. So x plus 3, quantity squared, minus 9 equals 0. To solve, we'll add 9 to each side, giving us x plus 3, quantity squared, equals 9. And now we can take the square root of each side, which gives us x plus 3 equals plus or minus 3. And now subtracting 3 from each side, we get x equals negative 3 plus or minus 3. So we have two answers here. Negative 3 plus 3 will give us 0, and negative 3 minus 3 will give us negative 6. So right now we have the point negative 3, negative 9, which we'll put in the center of our table because that's our vertex. We have the point 0, 0, because this is an x-intercept. The y value is always going to be 0. And then we have the point negative 6, 0. So now we just need 2 more points to complete our 5 points, 2 on each side of the vertex. And remember, we need the y-intercept at this point that we get by plugging 0 into the function. So that gives us 0 plus 3 quantity squared minus 9. 0 plus 3 is just 3. Squared is 9. Minus 9 just gives us 0. And you could have also found that by just looking at the table. Because the x value is 0, that means this had to be the y-intercept. So this point is an x-intercept and a y-intercept, meaning we need 2 more points. So we're going to go ahead and pick a number to the left or right of the vertex, and then use the axis of symmetry to find the other one. So let's just go ahead and pick -2, as it's close to -3. And then we'll use the axis of symmetry to give that same y value to -4, as it's 1 away on the left from -3, as -2 is 1 away on the right. So at this point, we're going to plug in -2 into our function, which gives us f of -2 equals -2 plus 3 quantity squared minus 9. -2 plus 3 is 1. Squared is still 1. Minus 9 gives us -8. So we get -8 for this x value, and because of the axis of symmetry, we will get -8 for the -4x value. We now have everything we need to graph this parabola, and I'm going to add one more tick mark here, as I didn't end up extending this far enough. So we have -6, 0 is 1 point. And I'm going to go ahead and switch this graph to red so it's easier to see. So -6, 0, -4, -8, -3, -9, and I apologize, I put that at -9. So -4, -8, let's try that again. Then -3, -9, which will be right here. Then -2, -8. And finally 0, 0. It's not perfect, and these sketches rarely will be perfect, but hopefully you can see the general U shape, which when you connect these dots looks something like this. And this is our graph. And remember, you could have used the axis of symmetry like so to find that opposite value, -4, -8, just like we did on the table, matching it over with a mirror effect. Alright, and finally from here we're going to talk about the other method for finding the vertex. This method essentially allows us to skip the completing the square step. It is much faster, but it still leaves the problem in quadratic form, which is a little bit more difficult to work with, but it is just your personal preference, whatever you feel is easier. A lot of students prefer this method, a lot of students prefer the other, so that's why we're going through both. So this method says given f of x equals ax squared plus bx plus c, the vertex is located at -b over 2a, comma f of -b over 2a. So, looking at this problem, f of x equals x squared minus 2x plus 1, we want to find the vertex. All we need are the values a and b. So a is the number in front of x squared, which is 1, and b is the number in front of x, which is -2. So -b over 2a is equal to -2 over 2 times a is 1, which gives us negative times negative 2 is positive 2, over 2 times 1 is 2, which just leaves us with 1. So the x-coordinate of our vertex is 1, and now we'll find the y-coordinate by plugging that 1 back into the equation. So we're going to find f of 1. We're plugging it into the function. So we get 1 squared minus 2 times 1 plus 1. 1 squared is 1. Negative 2 times 1 is negative 2. Plus 1. 1 minus 2 is negative 1. Plus 1 gives us 0. So f of 1 equals 0, which means the vertex is located at 1, 0. It's a much faster way, typically, of finding the vertex, but again, it doesn't end up giving you vertex form, and generally vertex form is going to be the easier way to go about finding your x-intercepts. So either way, it ends up working out the same, and it is worth knowing both methods, as you will typically be asked to find the vertex or vertex form. So you will need to know how to do both of them generally in mathematics. So find the vertex of f of x equals 2x squared minus 8x plus 3 is our next example. Go ahead and take a moment, pause the video, see if you can't find the vertex. Okay, trying this together, again we need to find negative b over 2a. A in this case is the number in front of x squared, which is 2. B is the number in front of x, which is negative 8. So we get negative times b is negative 8 over 2 times a is 2. Negative 8 is positive 8. A negative times a negative is a positive. 2 times 2 is 4. So that gives us 8 over 4 is 2. The x value of the vertex is 2. And now we need to find f of 2 to find the y value. So we get 2 times x squared is 2 squared minus 8 times 2 plus 3. 2 times 2 squared gives us 2 times 4. Negative 8 times 2 is minus 16 plus 3. 2 times 4 is 8 minus 16 plus 3. 8 minus 16 is negative 8 plus 3. And negative 8 plus 3 is negative 5. So f of 2 is negative 5, giving us a vertex of 2, negative 5.